Hello friends, welcome to my channel. I'm back with the third and last part of classification based predictive modeling. In the first two parts, we understood the advanced analytics journey path, most used techniques to build the model, how predictive models work at training and deployed state. We discussed question and answers around this for better understanding. We discussed modeling steps, data integration, data sampling, and defining the scope of predictive model. In this part, we will learn performance and observation period of a model, feature engineering, binning, stepwise association analysis, multicollinearity, and PCF, test and train the model, out of time test, model accuracy, lift curve, and model deployment. So let's begin. In any classification model, we study how long back into the history we find a pattern that help predict an event. Also, we need to ensure the performance period, that is the timeline of predictability. For example, employee attrition model to predict attrition in next 60 days or customer churn model to predict churn is in next 7 days. This is the design phase of the model, basis which it will get training and deployment. In this picture, we are taking 6 months as observation and 1 month as performance. This, in other words, we are observing last 6 months behavior to find a pattern for the event to happen in next 30 days. Performance point is the point before and after which performance and observation period starts. In a deployed model, this is also called model run rate. So let us understand this better with an example. Below is the analysis of the employee data with 10 years history. What would be a performance point, observation period and performance period? Average stay of an employee in the company is 3 years. There are 900 unique employee IDs in the database, but 100 employees are currently active. More than 90% of employees who have joined in last 10 years have left organization in some point of time. Data is from January 2009 till December 2019. In July month, attrition was high due to new competitor entered the market. Due to performance-linked incentive payout, many prefer to stay till this is paid till August every year. May attrition always high due to appraisal discussion. Increment letters distributed in June month. Some employee leave after this. So this is the situation. Using this situation, we need to create a timeline. We need to jot down each and every event and then decide how we are going to set up the performance period and observation period, or say performance point. So moving next, so this is the answer. Here you can see the timeline. So January 18 till June 19, and there is a seasonality due to appraisal, seasonality on increment, competitor entered, so there was attrition, lot many people joined the competition, seasonality on incentive payout. So what has been done is the 6 month picked where the disturbance was minimum. So September 18 till Feb 19 taken as an observation period, and 30 days March 19 as a performance period. So we are going to study last 6 month behavior pattern of an employee to find out an event of attrition in the month of March. Now let us understand data exploration and transformation. These are the most common activities done during data exploration and transformation. So let us understand these activities. Outlier treatment. Outlier treatment is exclusion of records with abnormally high or low values to remove bias. Missing null value treatment is the removal of records with null values. We need to be cautious that we should not remove large number of records doing this treatment. Data quality check is to ensure data types and values are accurate. Feature engineering is creating calculated fields that help enhance predictability of the model. Binning is converting continuous values into categorical values to help enhance predictability of the model. We will understand the feature engineering and binning in detail. Let us understand feature engineering. Feature engineering is the process of using domain knowledge to extract features from raw data via data mining techniques. These features can be used to improve the performance of machine learning algorithms. We have been discussing the data sets to create a machine learning model to predict the employee attrition. So these data sets we can create features like age to years in current company, age to total work experience, total experience to number of companies served. These are called ratios. Average hike to current year hike. So a person who has got more than average or less than average, if that particular feature can predict employee attrition, distance from home, years since last promotion, years with current manager, right hand side column you can see the calculation. So all these calculated values can help enhance the predictability of the model. This is called feature engineering. Let us understand this with an example. Below data columns are received from an agency that sells product AMC to the customer. Need to develop a model to predict who will purchase AMC. So if you look at the data, this is a ABT data where there is a customer code, product ID, component ID, and transaction number 1, 2, 3, 4, 5, 6, 7. These transactions are number of times a customer did a transaction in terms of AMC after the product was purchased. So using this data, if I need to create or you need to create features, how these features could be. So let us see. There are certain ratio, there are certain calculated variables. Ratio product age to MC age. So that means if product is 7-year old, suppose AMC starts after 2 years, 2 years AMC free with the product, then how many times this AMC has been taken? Rank product age to AMC age. This is to rank of ratio. AMC count, number of times AMC has been taken, age of AMC, mean price, month, average AMC price to all transaction, total number of calls customer has made, age of a product, product rank. So these, even pin code, suppose a particular geography customers are more keen to get into AMC for certain geography, uh, customers are not very keen, maybe because there are local availability to provide support. So B2C and B2B behavior is whether this product has been sold to an individual or to a institution. Multi-product means if a customer has taken more than one product. So these can be the created calculated values. Now let us understand binning. Binning is a method of turning labels or continuous variables into categorical values. This is accomplished by grouping the values into a predefined number of bins. An example is given like education. So education can be very confusing for a model. If we can group the education into professional, postgraduate, professional graduate, professional diploma, uh, general postgraduate, general graduate. So if we can give these category and put all of the employees into the category, so we can look into the education factor to correlate with the event of attrition. Satisfaction also, extremely unsatisfied, somewhat satisfied, satisfied. So this can be also categorized 1, 2, 3, 4. performance rating, non-performer contributor, significant contributor, exceptional contributor, because model may not understand the label as it can understand the category. Similarly, job involvement, job level, lower management, middle management, higher management. So these can be categorized. Now coming into the group, so there can be different age group. So I can create the bins 18 to 22 1, 23 to 25 2. So these continuous variable of age from say 18 years to 58 years of age or 50 plus years of age, I can categorize into bins to study the behavior. Let us understand techniques used for feature binning. So there are two techniques, one entropy based binning, which is supervised binning. So that is a formula based binning, and there is equal depth of frequency binning. So I have been using very frequently equal depth or frequency binning. So this is a process. We divide the range by intervals. In an Excel, we can simply sort the values from top to bottom. Let us understand each intervals and try to create similar number of records for every interval. So equal frequency may not be possible due to repeated values. However, we would like to create a good frequency distribution, and this is one way of doing a binning. A more accurate would be entropy based binning. So now we have set the performance on observation period, we have done the feature engineering, binning. Now let us understand what is stepwise. Our ABT is now complete. Stepwise is reducing the number of independent variable. If we have created 500 independent variable and try to predict an event, trying to associate all of these with the target variable, so we need to reduce from these 100 or 500 to some 6 to 10 significant, most significant variables. So how we are going to do this is called stepwise regression. Stepwise regression, we just try to keep removing from the number of significant variable and keep testing the accuracy of the model. We continue to do till desired accuracy is retained. So by removing the least significant variable again and again, this is a iteration, we help in getting a larger picture on model accuracy. This also helps reducing non-significant variables. After reducing variable through stepwise regression, we do association analysis. Association analysis to test the correlation. The most commonly used techniques are scatter diagram method, Pearson product movement coefficient of correlation, Spearman's rank correlation coefficient. Here you can see there are certain variables. We are trying to see the association measure and the p-value and the relation. Relation is nothing but, for example, age has inverse correlation. So that says higher the age, lower the chances of employee to leave an organization. Similarly, percentage salary hike, higher the salary hike, there are lower the likelihood that employee would leave. Total number of working years is also inverse correlation. Years in current role, inverse correlation. However, distance from home, higher the distance from home, higher the chances. So that has a direct correlation. P-value is percentile value. So mostly less than 0.001 is a good significance to use that particular variable in the model. So association analysis is a good way to identify the most significant variables that should be used to prepare or to build or develop the predictive model. After we test the correlation, we also test multicollinearity. Multicollinearity is two variables having, say for example, weight in kilogram and weight in pounds, two variables having weight and height. So the issue, there are larger number of independent variables in a regression model. These are correlated, and this correlation could be a problem. This can create a overfitting of a model. How to test high variation inflation factor? So we can calculate VIF, and VIF should be less than 5 or less than 4. Then it is not, there is no multicollinearity issues. If it is higher, then we need to remove certain variables. We need to drop independent variables with high collinearity. This is important in regression kind of techniques. However, in a tree-based model, generally multicollinearity does not impact the accuracy. In the reducing technique, principal component analysis is another way to reduce variables. PCA helps in preserving as much as information possible with reducing number of variables. It reduces time and storage required. So why do we need to reduce the variable? This is very important to understand. Removal of variable improves the interpretation of a parameters of a machine learning model. It becomes easier to visualize the data when reduced to very low dimensions. And PCA also reduces overfitting issues. Now the next part is testing, training and validating of a model. Model is trained against highly significant variable after reduction techniques. Now we divide this data into test, train and validate to avoid overfitting issue. Overfitting issue is during the training of the model we are getting a very high accuracy. However, while testing out of time, we do not get that much accuracy. So to have a stable model, the accuracy should be similar in a test, train and validate model or data set. So when accuracy level is similar into all these validation sets, so model can be finalized. Finalized model is ready for out of time test. Now we will understand what is out of time test. So here is a pictorial view to understand out of time. I have created model for a performance point between July and August. This model has been created during last 6 months from Feb 20 to July 20 to predict August 20. Now this particular model, I have done everything, all the steps I have followed, this algorithm is now ready. I will test this particular algorithm with a different time series, different timeline. So what I am going to do, from September to Feb 21, I'll take observation period and March 21 as a performance period, and I'll try to test my model whether my model accuracy is similar. So this is called out of time test. This is very important. Now after out of time test, we will look into model accuracy. Let us understand that the model accuracy values that has been generated by modeling tools is based out of these parameters. So true negative is model has been predicted negatively and this is true. False positive is model has not predicted but this has become true. False negative is vice versa. So there are four parameters basis which the model accuracy is tested. However, whenever the event rate is very low, this particular way of testing accuracy may not be the right way. Just to give an example, if there is 3% or 2% churn, employee churn, I'm going to create a model. So large set is actually not churning, 98% employees are not churning, and if a model predicts anything, so there are a large number of sets are true negative. So model is not predicting, employees is also not leaving. But these 2%, where does that fall? So I'll tell you the different way to calculate accuracy. So we can sort probability score from highest to lowest, split probability score into deciles. Highest probability in decile 0, map actual event in the score dataset, calculate as percent accuracy number of events in top 2 deciles divided by total number of events in complete population. So if it is more than 80%, so that's a good model. Just to give an example, suppose total population is 1000, total number of churners are 90. So number of churners in top 2 deciles 72. So the model accuracy is 80%. So this is a one way to calculate accuracy when the model is in a sense not distributed perfectly, in a sense only 2% are the event, 98% uh, are not into the particular event. Now let us understand the lift curve. So this is generated by the tool we use to create model. So this is called lift curve. Lift curve, how to understand lift curve is these are deciles. So in the x-axis you say 2, 4, 0.2, 0.4, 0.6, 0.8, and in the y-axis it's a true positive rate. So true positive rate is 0.8, is more than 0.8. So the accuracy of the model should be read as 84%. So this is how we see the accuracy, but there are other factors as well. So there is a recall, optimal probability cutoff, precision, and F1. F1, the higher the F1 score is a better quality model. So in this particular picture, F1 shows 0.35. So this model can be improved further. Now let us understand model deployment. So deployment is nothing but automating the model such a way we can set the frequency of weekly, monthly or daily, and this model should integrate with the data source systems, fetch the values, create the calculated field, input these calculated fields to the model algorithm and generate the output, save the output in a table. So this should happen in a completely automated manner. So there are few tools that generate deployment codes in Java, SQL, that can be placed in a ETL code for score generation, and these ETLs can be scheduled. Uh, this requires ABT to be pre-prepared by ETLs. So if there are calculated fields, ETL can be written and stored in a table and in a particular frequency refresh cycle. Alteryx is one tool that saves the trained model as a data file and used by the score tool. And that particular score tool flow can be scheduled. So every time it runs, it fetches the value from all data source systems and generates the output. SAS generates the deployment code in base SAS format that can be placed in SAS BI ETL code section, and that can also be scheduled. So there are n number of ways to deploy a model. So with model deployment, we complete the basic understanding and the basic steps towards building a classification based model. Friends, thank you very much for watching my video. I will look forward for your feedback and any question and answers. Thank you very much.